Okay, so the next where we're headed is to talk about the properties of logarithms. And there's three specific properties that I wanted to talk about. So let's first look at log base a of x times y. Perhaps you know what to do. The property of logarithms is that you, instead of multiplying, you can add them. So the log base a of x plus log base a of y. Number two, we got if we have, instead of multiplication, we have division. Then that's going to equal log base a of x, but then you subtract log base a of y. Third, we have one last property, log base a of x to some exponent. Let's call it c. The property here is that you bring down the exponent. It can come outside the logarithm. And there we go. We got our three properties of logarithms. These are classic, and like I said, that they invented logs to really deal with multiplying really large numbers. And you can see how that would be helpful because we have x times y, so you're multiplying really big numbers, and then it turns into addition. So that's why it was invented, but like I said, it's got this wonderful property that they're inverses of the exponential functions. So we're going to really use that here in calculus. It's going to be really nice. So let's do an example using these properties. So write as a single logarithm. Okay, so we got log of 5x plus log of y minus 3 log of z. Okay, so first of all, we notice that we have a 3 outside the logarithm, and we're going to put it inside. And we can do that using property 3. So we got log of z, and then it becomes our exponent. Okay, then we see that we have an addition sign, and that is going to mean that we can multiply. So we can bring it inside the log, and then instead of addition, we have multiplication. And just like that, we got rid of one logarithm. Okay, then we see that we have a minus sign, and we can use our second property, and that would be that you can combine them together, but then it becomes division. Okay, so here we go. We figured it out. We wrote it as one single logarithm. Okay, so we're going to have different things. So instead of saying write as a single logarithm, perhaps you have one log like this, and then you would have to expand it out using the different properties. So we're going to have different homework problems like that. Next major thing that I wanted to talk about is the change of base. Okay, and the change of base formula is log base a of x equals natural log x over natural log a. And you can see that you're changing the base number. So here we started out with the base of a, and then we end up with a base of e and a base of e. So we're changing the bases. So let's briefly discuss the proof of the change of base formula. So here we go. That's our formula that you can remember. And then remember, we're starting out with this left side, and then hopefully we can get to the right side. So let's say that that equals y. We'll change it into our exponential form, and then let's take natural log on both sides. Okay, then we can use property number 3 where we take the exponent down. And then we can get y by itself, and we get natural log x over natural log a. And if you look back, that's exactly what we said the change of base formula was. Okay, let's look at an example where we can use this. So, for instance, solve 3 to the 2x equals 5. Solve for x. So let's do two different solutions. Okay, so we got, let's put it in the log form, and we're going to do it in natural log form. So natural log, we're going to do natural log of both sides. We can bring the exponent down. And then, let's see, we want to solve for x, so we're going to divide both sides by 2 natural log 3, 2 natural log 3. And we get x equals natural log 5 over 2 natural log 3. Okay, and that's a specific number. If you look at your calculator, you can see natural log of 5, well, natural log on there. And if you put in 5 and then divide by 2 natural log 3, you get some specific number. It is 0.732, and it keeps on going. All right, so that one wasn't so bad, but you had to remember to take the natural log on both sides. So now let's do another solution. And so we got 3 to the 2x equals 5. Now, since you noticed that it is base 3, maybe we can put that in log form. So it's going to be log base 3 of 5 equals 2x. And that's just the logarithmic form, just from the definition. Okay, but then it's really nice because to get x by itself, you just divide by 2. So you get log base 3 of 5, but then you multiply by 1/2, and that equals x. Now, believe it or not, that is the same number, but we don't have a log base 3 on our calculator. We only have log base e or log base 10. So in that case, you would want to use our change of base formula. And that equals, here maybe I'll put it over here. So we got 1/2, that's along for the ride. But then we're going to do the change of base. So it says to multiply by natural log of the inside, so 5 over natural log 3. And you can see if you look over to the left that that's exactly what we got, doing it the other way. So either way you want to do it, and we'll still get the same number.